Ever pause to ponder the importance of clean water in your life? Water, the lifeblood of our planet, is indispensable to virtually every form of life. Clean water sustains our health, nourishes our crops, and fuels our industries. But just as water can sustain life, contaminated water can also bring about disease and environmental degradation. The quest for clean water has been ongoing throughout human history. From the ancient civilizations who first filtered water through charcoal, to the sophisticated purification technologies of today, our methods of purifying water have evolved dramatically, yet the goal remains the same: to ensure water is free from harmful contaminants, making it safe for us to drink and use. As we journey through this discussion, we'll explore various types of water contaminants, basic and advanced purification techniques, and the role of household, community, and industrial-scale purification systems. Remember, water is life. The cleaner the water, the healthier the life. Before diving into the solutions, we must first understand the problem. The water we consume and use every day, though appearing clear and clean, often carries invisible contaminants. These contaminants can be categorized into 4 primary types: physical, chemical, biological, and radiological. Physical contaminants are substances that affect the physical appearance or other physical properties of water. Examples include sediment or organic material suspended in the water from soil erosion. Chemical contaminants are elements or compounds. These can be naturally occurring or man-made and include bleach, salts, pesticides, metals, toxins produced by bacteria, and human or animal drugs. Biological contaminants, also referred to as microbes or microbiological contaminants, include bacteria, viruses, protozoan, and parasites. These tiny life forms can cause a variety of illnesses when present in drinking water. Radiological contaminants are uninvited guests in the form of chemical elements with unbalanced protons and neutrons. This results in an excess of energy that is released in the form of radiation. Examples include cesium, plutonium, and uranium. The sources of these contaminants are as varied as the contaminants themselves. Natural sources include the rocks and soil with which water comes into contact, leading to the presence of minerals, radioactive substances, and even some heavy metals. Biological contaminants can be introduced through wildlife or when the water is contaminated with feces. Human-made or anthropogenic sources of contamination are unfortunately plentiful. Industrial processes can introduce heavy metals like lead and mercury into the water. Agricultural practices can lead to excess nutrients and pesticides contaminating our waterways. Even our homes contribute to the problem, with pharmaceuticals and personal care products often ending up in our water supplies. Understanding these contaminants and where they come from is vital. It's the first step in determining how to remove them and ensure the water we use and consume is safe. Understanding these contaminants is the first step towards their effective removal. Scene script. Let's journey back in time to the basics. Our ancestors knew a thing or two about water purification. They might not have had the scientific knowledge we possess today, but they certainly understood the importance of clean water. So, what were some of their go-to techniques? First up, we have boiling. This is as simple as it sounds. By bringing water to a rolling boil, we can kill most types of bacteria, viruses, and parasites that lurk unseen. It's a straightforward method that's been used for centuries, and it's still one of the most effective ways to purify water. Remember though, boiling won't remove chemical contaminants or particles, so it's not a cure-all. Next, we have filtration. This involves passing water through a medium that traps solid particles. Sand and charcoal are popular choices for this. Sand filters out larger particles, while charcoal, due to its porous nature, can absorb certain chemicals and improve the water's taste. It's like a two-step dance, where each partner has a unique role. Then, there's sedimentation. This method banks on the fact that heavier particles tend to sink. By allowing water to sit still for a period, the heavier particles will naturally settle to the bottom. This technique was used in ancient Rome, where large pools, known as settling basins, were part of their aqueduct systems. Again, this method doesn't deal with chemical contaminants, but it's a solid start in the purification process. Each of these techniques has its strengths and weaknesses. Boiling is great for biological contaminants but falls short with chemicals and particles. Filtration can handle solids and some chemicals, but it's not foolproof against all biological contaminants. Sedimentation works well with larger particles but isn't effective against smaller ones or chemicals. But why bother with these basic techniques when we have advanced methods, you might ask? Well, these age-old methods are still applicable today, especially in emergency situations or in areas where access to advanced purification systems is limited. They remind us that solutions often lie in simplicity. These age-old methods are still applicable today, reminding us that solutions often lie in simplicity. As technology advances, so do our methods of water purification. The first of these advanced methods we'll explore is chemical purification. This process often utilizes chemicals such as chlorine or iodine to kill bacteria and viruses. Chlorination is commonly used in municipal water treatment facilities due to its effectiveness and low cost. It's like the bouncer at the club, keeping the bad guys, or in this case harmful microbes, out of our drinking water. Iodination, on the other hand, is often used in emergency situations or for travel purposes. It's the portable bodyguard of water purification. Next, we have the superhero of the purification world, ultraviolet radiation, or UV radiation for short. This method zaps away harmful organisms with UV light, effectively disinfecting the water. It's quick, it's efficient, and it doesn't alter the taste of the water, making it a popular choice for both home and commercial use. Then we have reverse osmosis, which sounds like something out of a science fiction novel, but is actually a highly effective method of water purification. It works by forcing water through a semi-permeable membrane, trapping contaminants on one side and allowing clean water to pass through. This method is a bit like the overachieving student in a class, going above and beyond to ensure the water is as pure as possible. Finally, we come to distillation, one of the oldest methods in the book. It involves boiling water to produce steam, then cooling that steam to collect pure water. Despite its age, distillation is still a highly effective method of purification, kind of like the wise old sage of water purification methods. Each of these methods has its own strengths and weaknesses and are used in different contexts based on their suitability. But one thing they all share is their ability to provide us with clean, safe drinking water. These advanced methods, though complex, ensure we have access to clean water in the most challenging circumstances. Clean water starts at home. As we journey into the realm of household water purification systems, it's fascinating to see how these mini marvels of technology help keep our water safe and clean. First, let's dive into the world of water filters. They're the most common purification system found in homes. From simple pitcher filters to complex under-sink models, these systems primarily use activated carbon or charcoal to remove contaminants. They're effective against chlorine, sediment, and volatile organic compounds. But they may not be the best choice for removing heavy metals or bacteria. Maintenance is usually a breeze with these systems. Just remember to change the filters regularly to keep them working efficiently. Next, we have water purifiers, a step up from filters. These systems use various techniques, including reverse osmosis and distillation, to remove a wider range of contaminants. They can tackle heavy metals, bacteria, and even some viruses. However, they're often more expensive and require more maintenance than filters. It's a small price to pay for an added layer of protection, wouldn't you say? Lastly, we have UV systems, the high-tech heroes of water purification. They use ultraviolet light to kill bacteria and viruses, offering a chemical-free purification method. These systems are especially effective in areas where microbiological contaminants are a concern. On the downside, they're not effective against chemical contaminants and they require a steady electricity supply to function. So which one is the best? Well, the answer isn't that simple. The right system for you depends on the quality of your source water and what contaminants you're most concerned about. It's always a good idea to get your water tested before deciding on a system. And remember, even the best purification system isn't a set-and-forget solution. Regular maintenance is key to ensuring they continue to provide clean, safe water. It's your first line of defense against waterborne diseases and contaminants. Choosing the right system for your home is crucial for ensuring clean and safe water for your family. So take the time to research, understand your needs, and make an informed decision. After all, the health of your family could depend on it. Clean water is a community responsibility. It's not just about the water we drink in our homes, but the water that flows through our cities, towns, and industries. Large-scale water treatment plants play a crucial role in ensuring that the water we use every day is safe and clean. Imagine a city bustling with activity. Every day, millions of gallons of water are needed to keep this city running. To meet this need, water is drawn from various sources like rivers, lakes, and wells, which is then sent to water treatment plants. These plants are like giant versions of the water filters we use at home, designed to clean water on a massive scale. The process begins with coagulation, where chemicals are added to the water to bind together the tiny particles of dirt and sediment into larger clumps. These clumps then settle to the bottom of a large tank in a process known as sedimentation. Next, the water goes through filtration, where it's passed through layers of sand, gravel, and charcoal to remove any remaining particles. After filtration, the water is disinfected, usually with chlorine or ultraviolet light, to kill any remaining bacteria or viruses. But the job doesn't end there. After the water leaves the treatment plant, it's continuously monitored to ensure its quality. Samples are regularly tested for a variety of contaminants, ensuring that the water that reaches your tap is safe to drink. This process is overseen by government agencies that set strict standards for water quality. These regulations are crucial in protecting public health and ensuring that everyone, no matter where they live, has access to clean and safe water. But it's not just about government regulations. It's about communities coming together to protect their water sources, industries minimizing their impact on water quality, and each of us doing our part to conserve water and keep it clean. Clean water is a shared responsibility, and it's one that we all must take seriously, because when it comes to water, every drop counts. Together, we can ensure clean water for all. Innovation is the key to solving our water challenges. As we delve into the realm of emerging technologies and research in water purification, this sentiment becomes increasingly clear. In the relentless pursuit of clean, safe water, scientists and engineers worldwide are developing new, innovative, and sustainable methods to purify water. One such technique harnesses the power of the sun. Solar water disinfection, or SODIS, is a simple yet effective method that uses ultraviolet light to kill harmful bacteria and viruses. Another exciting development is the advent of Biosand filters. These ingenious systems use natural biological processes to remove pathogens and contaminants. A layer of beneficial microorganisms forms on top of a sand bed and works to neutralize harmful substances in the water, providing an effective, sustainable, and eco-friendly solution. In the realm of nanotechnology, we find another promising innovation: graphene-based filters. Graphene, a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice, has unique properties that make it ideal for water purification. These filters can effectively remove even the tiniest contaminants, including salts and heavy metals, offering a potential solution for desalination and other challenging purification tasks. The world of water purification is also witnessing the rise of bio-inspired materials. For instance, xylem filters derived from plant tissues can effectively filter out bacteria and other contaminants. These filters are both sustainable and biodegradable, making them a promising solution for the future. In the sphere of chemical innovation, there's the development of photocatalytic materials. These substances can harness sunlight to trigger chemical reactions that break down pollutants, offering a self-cleaning, sustainable method for water purification. These emerging technologies are not just theoretical. They're being applied in real-world situations, from rural communities in developing countries to advanced water treatment facilities in urban areas. The future of water purification is not just about new technologies, but also about the integration of these technologies into existing systems and the development of scalable, affordable, and accessible solutions. The ultimate goal is to ensure clean, safe water for everyone, everywhere. The future of water purification is bright and promising. Clean water is in your hands. Yes, it truly is. With a few simple steps, you can ensure the water you use is safe. Let's go over some practical tips. Testing water quality at home is easier than you might think. Basic water testing kits are available online or at your local hardware store. They can detect common contaminants like lead, chlorine, pesticides, and bacteria. Just follow the instructions and you'll have results in no time. Can't get a water testing kit? No worries. There are do-it-yourself purification methods that can come in handy. Boiling water for at least 1 minute can kill most types of disease-causing organisms. Or you can create a simple water filter using sand, gravel, and charcoal. Lastly, remember to conserve water. Fix leaky faucets, opt for shorter showers, and use a water-efficient washing machine. These small actions can make a big difference. With these tips, you can play a part in ensuring clean water. Clean water is a global challenge. As we speak, nearly 1 in 3 people worldwide lack access to safe drinking water, an issue exacerbated by climate change and population growth. Climate change, with its rising temperatures and shifting rainfall patterns, affects water availability and quality. Droughts become more frequent and floods more severe, both contaminating water sources and making them scarce. Meanwhile, population growth and urbanization stretch the existing water resources thin, leading to conflicts and social unrest. It's a vicious cycle, with the poorest being the most affected. But there's hope. International organizations like the United Nations, the World Health Organization, and non-profit entities are stepping up, investing in infrastructure, promoting water conservation, and innovating new purification technologies. From desalination plants in Israel to solar water disinfection in India, these efforts are making a difference. Yet, this is a shared responsibility. Every drop saved, every clean water initiative supported, brings us one step closer to solving this global crisis. The fight for clean water is a fight for humanity. Clean water is our right and our responsibility. As we've journeyed through the world of water purification today, it's become abundantly clear just how vital this process is. From basic methods like boiling and filtration to advanced techniques involving UV radiation and reverse osmosis, we've learned that ensuring clean water is both an art and a science. We've delved into the workings of household systems, explored large-scale industrial setups, and even glimpsed the future with innovative and sustainable technologies. We've offered practical tips and touched upon the global challenges that face us. Each drop of water we consume has a story, a journey. It's a narrative of purification, of overcoming contaminants, and arriving safe and clean. As we go about our lives, let's remember this story. Let's be mindful of our water usage, of the quality we demand and the waste we prevent. Let's cherish and protect our water, for it is the source of all life.